welcome back. This tutorial line is basically based on sheet metal module, and today in this tutorial we are going to cover some topics regarding the sheet metal, and we'll make a project on sheet metal. We'll have the idea of the commands like extrude, or we can also say in terms of CATIA this extrude is called wall. And basically our first command is sheet metal parameter, and in which we'll feed the sheet parameters. Second is wall, third is bend from flat, fourth is wall on edge, and then unfolding and cutout, and then we will see about rectangular pattern in the sheet metal also, and we'll have some idea of mirror command. Then finally we'll sum up with folding. Now let's see these commands one by one on the CATIA software and launch this V5 version. Basically these commands are based on the sheet metal, so we'll be launching the sheet metal workbench of CATIA V5, and its name is generative sheet metal in this CATIA V5. So now let's switch to CATIA and see the changes. As I said, let me change its name as generative sheet metal. So here we are in CATIA. Let's go to start, mechanical design, and generative sheet design. Let's give this a name of exercise 1 and press OK button. We are on the interface of our CATIA. Let's feed the sheet metal parameters, which was our first topic to be covered. Let's give the thickness of 0.6 mm and default bend radius to be 0.3 mm and press OK button. Now let's take the sketch on the top plane. Here I'm going to make a rectangular section, a center by the centered rectangle. So let's just draw this. Our first topic has been covered, which was the sheet metal parameter. Now let's switch to the second topic, which is the wall. So I have created a profile for wall to be done. Let's say I have defined the horizontal side to be 300. Let's change this up to 300. It's fine. And now let's give the vertical side to be up to, let's say, 400 plus 200, because I'm going to fold it from flat, bend it from flat. So this is my profile, and I'm going to make a wall definition on this on both sides of the material. So this is the sheet metal wall which has been created from the rectangle profile. Now let's take this sketch on the top plane and perform the command bend from flat. Bend from flat is basically a sketch bend in which we need a sketch. So let's draw a line from where you want to bend this. Let me give it a constraint up to, let's say, 100 mm. So I've created a line on up to 100 mm from the edge, topmost edge. Now I'm going to choose the bend from flat definition, and this is my fixed point which I need on a side which I want to fix. So as you have seen, I switched or changed that fixed point. Now let's draw the profile again for the second bend and give it a distance of 100 also. Let's again go to bend from flat. Let's switch the fixed point, and it's done. So as you have seen, the fix bend from flat. Now wall on edges is the next command. So wall on edges is the edge wall created basically. So let's select the edge where you want to create the wall. Now let's give it a distance of 100. Let me zoom in. As you can see here, distance is not as same as the wall on the side, so let me switch the distance of other type. It's looking pretty effective. Now let's create the wall on the other edge. Let me rotate this. Not exactly oops, I took the bend from flat definition. Let me close this. Let's go to wall on the edges, click on the wall, and it's 100 mm up to, and let me change the type of height definition. So if I zoom in, this is looking at the equal level. So here I have created a sheet metal box like structure. Now let's again go to wall on edges and create another wall on these side walls, and this time I'm gonna take the distance of 60. So height of the wall will be 60. Let me change up the type of the height to be taken. Let's go to wall on the edges again and select the outer edge, and the distance is same. Now let me change the height definition type, and this is created. Now if you want to change anything or cut anything from this sheet metal part, so we first have to unfold this, because my profile is already folded. So what I'm gonna do is unfolding, and I'm going to select all the things, but I have to make sure that I have given the reference. Now let me go here. I have folding and unfolding, but unfortunately it's not working just because I did not give the reference element. Now again go to unfolding definition, and let me select the reference face to be as bent face, and I'm going to select all and preview and OK. So this time I have done, because I have chosen the reference plane to be bending plane. Now let's take the sketch on the surface of the sheet metal, and let me confirm the position. Actually isometric view is like this. So I'm going to cut out some material. Okay, now let's take a sketch of let's make a circle on the center, and let me give its diametral constraint to be 100. Now let's check the vertical distance from the horizontal axis to be 200, and let's get out of this sketch, and let's make a cutout here basically. So the next command, which is also here, the cutout. So let's perform this cutout. Here we have the cutout. Now let me select the sketch, press OK button. So we are done with the cutout section from the sheet metal. Now let's take the sketch on the top surface from the top portion, and let's make a D slot. D slot is the half portion of the slot. So let me first make the straight slot, give it a value of 5, means the radius should be 5, and let me define the constraint from the top edge, which must be 25, let's say, and let me define the horizontal constraint, which should be 75 and approx 75. Now I have created a line to part this, and let me trim this. So this is my D slot created. Now I'm going to translate this profile. So to translate the profile, just select this, go to translate, click on a point, pick point from where you want to make a translation. Give an instance is one less than the number you want. Suppose you want the number to be 6, so you will be giving the 5. Now after giving the distance, translation is done. Now let's get out the sketch and make a cutoff. So by this we are done with these. Now next thing what we are going to do, we're going to cut other sections from the other faces. Let me take the sketch on this face and draw a pattern. Let me take a center rectangle, and I'm going to give a vertical side of this rectangle to be, let's say, 20, but not exactly. Let's give it a 10, and give the horizontal side to be 20. Now just because this rectangle is a centered rectangle, so let's give its center to be at 20 distance from the outer edge, and 20 from the, and 40 from the vertical edge. Now let's make the other rectangle. This is a part of our pattern what I want to make for a cut section, for a cutout. Let's give it a 10 distance and give the other rectangle to be 20 for its vertical edge or vertical side. Let me change this horizontal value from the edge to be 20 at 20. Now let's trim the edges of inner side. So here I'm done with this profile which I want to make cut out of. Let's go and make a cutout. Now this is the profile which I want to make a rectangular pattern of. So our next command to be covered is the rectangular pattern. So let's go to rectangular pattern. For that I want to select this cutout, select the cutout and go to rectangular pattern. Give the number of instances, total number of instances you want. Let's say I want the number of instances to be 4, and spacing between the two instances, let's say, be 40, and give the reference element to be the edge. Let me change this spacing to be 80, let's say, and you can take a preview of this and click on the OK to confirm the command. So this step I have done. Now I have done this thing. Now let me draw again the same profile at some distance from the previous row. Let me draw the other rectangle. Now let me give the constraint from the vertical axis itself. Let's say it's be 20, and the horizontal edge it should be at 60, let's say, and make the other rectangle centered rectangle concentric to the previous one. Now let's give it 10 and 20 again, and go to trim all those things, all those inner extensions, and get out of the sketch. Let's make a cutout on this and make a rectangular pattern of this cutout. Select the reference element, give the spacing, So we are done with the rectangular pattern. Now let's make the other profile to be cut out. This profile is again going to be a D section. Let's give radius to be at 10 and give the distance from the top edge to be at 30 and the center axis to be at 40 and this corner point from the right edge to be at 30. Now next thing to do is to cut the other part from the slot to make it a D section. For that we will be making a line and trim all these parts, extra parts, and get out of the sketch. Let's make a cutout from this, and I want the same thing to be done on the other side, so for that I'll be making a mirror. So basically our next command is also based on symmetry or the mirror. So next command is mirror. Let's perform the mirror. First let's get out of the sketch which we were in and select the cutout, go to mirror and select the element to mirror. So chosen this front side plane for the mirror. Next command, not exactly, let's take the sketch on other face also and make some other patterns to be cut out. Let's make a corner rectangle, and it's not a rectangle, it's a square, so let's give it 10 by 10 constraint, 10 by 10. Now let's position, give it a position from the edges also, but it's look, let me delete this first and shift the rectangle, then again go to give the distance constraint from the edge. Let me give this distance to be, let's say 10, and give the bottom edge to be at 10 again, and let's get out of the sketch. Let's make a cutout of this profile. Now let's make a rectangular pattern of this cutout. Let's give the number of instances to be, let's say 7, and spacing between the two instances to be 30, and select the reference elements. This is the first direction rectangular pattern definition, and on the second direction I want the second instance, and let's give this spacing to be 40, and let's select the reference element and take a preview of this. Confirm the command. So by this we have done. Now let's again take a sketch and make another corner rectangle, and give, not exactly rectangle, let's make a square, and give it a position constraint, let's say 30, and 10. Let's get out of the sketch, make a cutout, and let's make a rectangular pattern again for this cutout. Select the reference element, reverse the direction. On the second direction, let's select the reference element, and now we have done. So we have created all the cutouts and patterns from this. Now let's take the sketch and make a wall of the profile, something like rectangle. Let's give it a horizontal constraint to be 50, and distance from the vertical axis to be at let's say 25, and obviously other thing to define the top edge from the horizontal axis, position from the horizontal axis to be at 300, and finally the height of this rectangle to be, let's say, at 125. And let's make a wall of this profile, and make sure that you have created a single sided material type of wall, and let's invert the material side to be merged from the previous one. So this type we have created this rectangle. Let's take the other sketch to make the end as circular. Let's select the edge and the circle and make them tangent. Now let's again select the circle and edge and make them tangent, and make a line for this section to be cut. Now let's trim the extensions and trim the circle also. This is the profile I want to make a cut section of, cut off. So let's perform the cutout, and let's mirror this cutout about the YZ plane, and this time we are done with the profile, and the next thing to do is to fold this again. So let's perform the fold. Select the reference face and select the fold faces, but reference face should always be a folded face, and click on the select all, click on the preview and click OK button. Oops. Now you can see that the wall which I made has left on this space which is in vain. So let's delete this wall. So do not create a wall which is not a part of a sheet metal, otherwise it's left behind, and when you are performing some actions after unfolding this. Now let's make the wall on the edge again. Let's select the inner edge and go to extremities and left offset to be at 150, not exactly, let's give it a value of -125 from the left offset, and right offset to be at again -125. So the remaining part is having the width of 50. Let's give the height to this at 125. Now let's make a sketch and make it normal. Let's make a circle again. Make this circle tangent to top edge and side edge. To make the end circular, let's make the line like last time we did. Let's make another line tangent. Let's trim the extensions and the circular portion. Get out of the sketch and make a cutout of this profile. Click OK button. Now let's make a mirror about the YZ plane again, and we have got a semicircular portion on the end. The next thing is to bend from flat. So let's take the sketch on the bottom portion and make a line. Let's give this line, let's position this line to be at 35 and get out of the sketch. Make sure that we have a fixed point, because it's a major concern to be defined, it's a major thing. Let's click on this one to be fixed point. So this fixed point should be at a proper place, it should not be on the bench as you can see here. So let me define the position for the fixed point first, and it should always be on the face where you have taken the sketch. So let's make a reference point here. Let me define this point again on the face and click OK. So here I have defined a reference point. Now again go to bend from flat and click on this point to define it as a fixed point and take a preview. So it's done. Basically the requirement of the bend from flat is to define the fixed point. Again make a fixed point on this face and make a sketch on this face again. Make a line to bend it from flat, bend the sheet metal from flat. Give this line to be at 30 and bend it from flat, define the fixed point and click OK button. So here we are done with the profile, all the bends and profile. So I'm going to conclude my tutorial here. Thanks for watching video tutorials from CAD Desk head office, and stay tuned.